Hello and welcome to our lesson on solving polynomial equations in factored form. So factored form is something that we will be exploring in our next few lessons on how to factor quadratic equations and polynomials, specifically trinomials. So there are a few video lessons posted in Google Classroom for you to explore and build a foundation of an understanding of factoring basics based for next week. So that video assignment will also be good assistance with this lesson to help you understand what factored form is. So in this lesson, I'm not going to go too much into depth on factoring or the process of. We are just going to accept that these equations or polynomials have already been factored for us, and we are just looking at the process to solve for our variables. Then in our next few lessons, we'll go through the process ourselves of how to take a quadratic or polynomial and factor it to look like some of these problems. So it may seem like we're going a little bit out of order, but that is so that you understand how to solve these, and then we'll look at the process on how these equations get created. So for today's lesson, the main property that we'll be applying is the zero product property. And the zero product property states in any equation, if it's a times b equals 0, then we know a equals 0 or b equals 0. Because in order for two values being multiplied for their product to be 0, a or b, one of those two factors, has to be 0. Now that idea is what gets applied to and allows us to solve these polynomial equations in factored form. So if we look at example 1a here, we'll see our equation is two different binomials, x plus 17 and x minus 12. So we have two different binomials in parentheses, which means they're being multiplied. So even though there's no multiplication symbol in here, technically what this equation is the quantity x plus 17 being multiplied by the quantity x minus 12 equals 0. So that's what we end up with when we factor our trinomial quadratics. So in B, you'll see also, even though we have coefficients attached to x, we have two binomials, 2x minus 1 and 3x plus 4 equals 0. So if it's a binomial times a binomial equals 0, this first binomial could be A, second one B, if we're looking at the zero product property. Two different values being multiplied equals 0. So we can use the zero product property to solve. The way we do that is we split apart the binomials. So we're just going to write them separately and set each one equal to 0. Then you solve each for the variable. So in A, I'm just splitting my x plus 17 and my x minus 12 and setting each equal to 0. Then we want to solve each for x. So to solve for x plus 17 equals 0, we're undoing the order of operations. So we would subtract 17 from each side, and x equals a negative 17. Also, the x minus 12 equals 0. To solve for x, we have to add 12 to each side, and x equals 12. So this problem technically would have two different solutions. Could be x equals a negative 17 and an x equals 12. In B, 2x minus 1 gets split and 3x plus 4 gets split. We set each equal to 0. Then we need to solve each for our variable. So in 2x minus 1 equals 0, to solve for x, undo the order of operations. So we'll add 1 to each side and divide by 2. That means x equals 1/2. In the second part, 3x plus 4 equals 0. We need to first subtract 4 from each side and then divide by the 3. So x equals a negative 4 over 3, or a negative 4/3. So our two solutions there would be 1/2 and negative 4/3. Now in C and D, if they are written as just one binomial squared, so an x minus 9 to the second power, what that means is x minus 9 times x minus 9. Now, if we separate these and solve them, we're solving the same thing twice. So we only need to solve this once. So we take one of the x minus 9s and set it equal to 0. Add the 9 to each side, and x equals 9. So in a problem like C, we only have one solution, which is 9. In D, we have x plus 5 to the second power equals 0. So that's the same thing as x plus 5 times x plus 5. So solve one of those for x. So x plus 5 equals 0. Subtract 5 from each side, and x equals a negative 5. And then in E and F, if we have larger polynomials that get factored into more than two binomials, the process for solving these is still the same thing. We want to split apart all the binomials, set each binomial equal to 0, and then solve each for the variable. So we're going to take the 7x plus 3, set that equal to 0, 2x minus 1, set that equal to 0, and the x plus 5, set that equal to 0. Then solve each one of those for x. So when 7x plus 3 equals 0, we have to subtract 3 and then divide by 7. So x would be a negative 3/7. 2x minus 1 equals 0. So to solve for x, we have to add 1 and then divide by 2. So x would be 1/2. And then x plus 5 equals 0. Subtract 5 from each side, and x equals a negative 5. So in this case, 3 different binomials mean we'll have 3 different solutions. And in F, same thing, 3 different binomials being multiplied equals 0. So we split them and set each equal to 0. 3x minus 2 equals 0. So add 2, then divide by 3. X equals 2/3. X plus 4 equals 0. So simply you subtract 4, and x equals a negative 4. And 4x plus 9 equals 0. We would subtract the 9 and then divide by 4. So we would have a negative 9/4.